All right. So what I'm going to do is start with something simple and go through the whole process so that you see it in as quick as you can. And so here I'll just close without saving. I don't care. Okay, so here, hang on. For that matter. Here, I might be doing it like this. Force a quit. Okay, so here we're starting from beginning here. So your virtual machine will look almost like this, except these three items will be missing. And there's going to be two directories up here. But we'll deal with that when we get to it. So again, you want to do geometry, grid, solution, and then post-processing. So you start with the geometry. We'll do a new one, and we'll do about as simple as you can get. So for my geometry, I'm going to do that. I'm just going to squish this bar or make it a bar. So I'll make it kind of like that. And then what you do is you immediately head off. So in other words, if you're doing something complicated, you work for a while, and then you get your complicated part right here, and you're going to do this to it. You're going to go in, you're going to explode it into faces. And in this one, you only have three faces. You have the top, I bet that's the bottom, and then you get the center section. So what I'm going to do, let's see, I forget which one. I'm going to fix this one. I'm going to let this one be free, and I'll say I'll push on this one. So I got three surfaces. Now what will happen to you here is you may have a complicated geometry right here, and you may end up, instead of just three, you may end up with like 40 of these things. So it becomes a complicated thing to actually go through. So the best thing I would suggest is you're going to have a fixed location and something you're going to load, and then all the rest are going to be free. So what I started doing, I was doing one the other day, I just said F1, free 1, F2, F3, F4, and just go down the list. So the first thing is to find, I would say, is to find the ones you're going to load and the one you're going to hold. Label those, and then label all the rest free. And so if I do that, I'm fine. I'm all happy, and I'm done, and then I go to the meshing part. Hang on for a second. Then go in and create a mesh. My laptop doesn't go extremely fast, so it does go extremely slow though. So you end up with the name of the mesh, the geometry you're working off of. So if you highlighted this cylinder, it'll show up. If you ended up highlighting one of the surfaces, oh boy. I noticed on the virtual machine it didn't do this. You'll notice it moves directly to the 2D. So you really want to make sure the body or the solid that you're working off of is the one you click. And then it basically says, you're back in 3D. Here, the most successful I've found is the one that says NetG 1, 2, and 3D. And that's the one I found that behaves the best. And then I always, if you don't put any parameters, you can't adjust your mesh. And doing simple parameters are fine, but it's maybe too simple. So I always do this 3D so I'll have the most control I can. It pops up, and maybe this time I'll show you something about local sizes. So he says the maximum size and the minimum size. Now to me, I don't know what that means yet. What is that? Volume, distance, what? Here's what you can do. Okay, here I'll just call that F here, a bunch of letters. You'll see where that ends up in. Apply it and close, and what you'll see, there's the hypothesis. If you right click, you can edit it, and then you can start changing it. The algorithm, you can unassign it, And you could rename it, but you can't do anything with it. And then the mesh relates back to these two. So I can go add a hypothesis, rename it something, and point this to another one. But in the meantime, you just want to compute, and it probably won't take too long. So there's your mesh, so to speak. I'll hit my control, rotate it around. But let's say for a minute that I didn't like a couple of aspects of this. So I want to control some things on this mesh. So let's try something interesting. I'll go to the hypothesis, and you'll see something on local sizes. So I'll do a subface. Let's see if I can do off of that. And then change that. I don't know what 30 means, so how about 5? Okay, then I go back. You can see the little exclamation point shows up again. And then you'll see that's the compute. So this is the create the mesh, and this is the compute it. And it may take a few more seconds, but so what you'll notice, if I can roll it over here, you'll notice that part down there became a little, a little finer. Now I can go down in here and edit hypothesis, find that local size and say, okay, you got to be careful. If you go too far, you might be sitting here for like 10 minutes. So let's run it again. And what you see, it got a little bit smaller. So you can control the mesh size along the edges, along any of the surface. And you can see nothing happened to the top. It only happened where I was going to push on it. So here, I'm going to even go edit hypothesis. I'm going to go to that local size and change it to 1. I'm going to just kind of be a little bit unrealistic. Hopefully not too bad. Notice I snuck my drink in there. I'll have to edit that out of the video. Oh, here, close it. And now you see something ridiculous. Okay, yeah, it may be a little bit ridiculous. Maybe I need it, though. But look at it. I mean, I have tons of elements all along that surface now. And you can see it quickly refined itself away. You could play with this. And this is one of the things that might be good to do. Okay, so if I have a moderate, that's fine. What if I did a very fine? Now, or what you notice here is something called the growth rate, 0.1 versus 0.5. So let's do a very fine, which is a growth rate on there, and watch what happens. I don't know if you could remember what it was before, but you'll probably see something interesting, maybe. First thing you notice, it takes a little longer. Now what the growth rate is supposed to do is it's supposed to, the element is a certain size here. When you move away from that element, it grows slower. So it's not like an abrupt change of a bunch of elements on the surface to a big jump. And so you can do, and that's very important for accuracy, turns out. And you can do stuff like, okay, I want to control that very fine. So instead of a growth rate of 0.1, what if I did 0.05? I mean, I don't know. Hey, wait, something came up there. Here. Okay, specify either a variable or name with 5% input can be adjusted. It just says the value. Okay, so what was I doing? 0.05, wasn't it? You should notice now well, first thing you notice is it takes a few minutes. Because it's having to, and my fan's coming on and off more. So you start seeing slightly smoother transition, although it doesn't look that much, but you could pull that down to the point where actually, here, let me You can see the elements way far away or way too big, you know. But for the case of what we're looking at, it's probably okay. So I'll show you, go through this a lot in here where we're going to go through and see that. The reason I'm doing this is somebody is gluing this part to the table. So as it turns out, I'm going to shed the top of it down, just like a bar to your little baby. But what you're going to find is, this is a bar, it's a real bar. It's glued to the table. It can't slide apart. So when it's confined, it's almost as if somebody's coming along with you as you're shoving it to stay that distance. And up there, as it's being pushed out, it widens out. So what you'll see is like a shape that's kind of like this. So it's not truly P over AE. And you'll find your stress level is higher than what you expect. You know, you expect, you know, just P over A being the stress. It's not going to be that way, really. So let's just say we're good here. I'm going to go ahead, grab these three things. You have one other thing you need to do. Create groups from geometry. Now, oh, here, wait a minute. I got to specify my mesh. There it is. Now I got to specify my geometries. Okay, and then I'll just hit apply and close. All that happens is they show up under here. There is a way in which you don't do that, where you can reference these faces back up there, but I like to separate them because there's another thing in which if you run a fluid mechanics simulation, you have to have your faces defined down in here. So I get in the habit, I learned this code from a different standpoint. That was to do fluid simulation. And I always put the faces down here. So there'd be a list of these faces that are duplicates of up there. It just so happened it sat under the meshing part. And so, but that's okay. Now I'll head off to this Aster thing. But before I do, I think I'll save it. What is today? Is it March 16th, 2015? Let's just do that. Okay, so now I'm going to head off into this Aster thing. It spins around. Oh, it already is spinning around. Okay. Now I'll select the mesh, or maybe I shouldn't, but anyway, you have to eventually, okay? Now this is again, this is an application that's on top. It's only going to take a small universe of possible problems that CodeAster can do. It can do a whole lot of different things. It just so happens that he's put 4 bars or 4 icons up here for you to do 4 different type of problems. But you can do more than that. Select the mesh. Okay, I already did. I'm going to use the mesh groups. So that means these 3. Then I'm going to go in and have I'm not going to change that. I don't really care about that right now. Okay, so now I got, and I think the way this works, I haven't observed it too close, but I think what it does is it finds the first one in the list and puts it there, I think. But I'm not sure. I haven't run it enough to really, and be observant enough to notice that when I'm doing it. So I'll say, okay. Then I'm pushing it with 1, and then I'm going to free, put no load on the other. So I think I'm okay. I push it with 1, I'm free with the other, hit OK, and now I got to write a file. So again, this is still March, still the 16th. Okay, I hope those minus signs don't mess up, but I may have to change it. Okay, so it's writing around, and then it puts a bunch of stuff in this area. Some of this stuff you could go in and spend more time learning about, or you could do like me and just say, okay, well, sometime in my future I might start looking at these, and I might start looking at these, but for right now I'm fine with it. I just look up these things, I notice it's connected to the mesh in the last group. That's my file on my directory somewhere. So I think if you go delete that file, it stops working. So you go in, you do this, and you select the linear static or whatever it got named, and then you push go, And I don't know how, it depends on the size of the problem. But you notice something? Look, it says La Matrices S2. It's all French. A lot of this is in French. If you look, well, that's not in French. Okay, but a lot of it's in French. Okay, it said it was successful. It makes sense. The French wrote this thing. And it's pretty good code. So, okay, I'm going to save it again. I'm always worried that something's going to explode. The last thing I've got to do is visualize it. And so I hit the button, wait a minute or two. I think it actually runs quicker on the virtual stuff, but you'll be able to see. Comes up and there's nothing really there. And that bugged me at first. But then I realized, okay, wait a minute. When I was doing it using OpenFOAM and some of the CFD, you had to actually load it sometimes. You loaded it differently there. You loaded it from the command line, but you have to open your thing. And there's that's what it was called back in Codastr. So you load it, and the first thing is you hit apply. Okay, and there's my object. You can kind of tell it looked, these are the terrible elements. They're overly big. And these are the ones that I spent a lot of effort refining around. Hopefully I'm okay. But you don't see anything until you go to the display and you say, well, I want to show the color of the stress. Let's look at the stress. Okay, and I didn't have to hit that. What you notice is, take a look. Okay, so I don't know. Let's see, I put a load of 1. I don't know what the size of the bar was on, but PL over AE, and your stress being P over A. I don't know what A was, but in effect, what you see is all the stress is right there in that edge. Okay, so one of the things I should have done is I should have looked at that diameter, but essentially that stress is as a simple result of you glued the entire surface. The way I've done it is all this is fixed. So essentially, I put crazy glue out, and I stuck the thing on the table and let it glue it. And then I go along and push it. Well, it's pushing, and yeah, there's some stress. If you look at the little cube down there, you'll see there's some normal stress. But actually, you'll also see that there is some stress in this direction, holding this thing on. Because the table, or whatever I glued it on, is holding the bottom of it so that it doesn't expand. Here's what I mean. Okay, let's take a look at this. Okay, see if I can go back. Maybe zoom out. It looks okay. So I'm very annoyed that it doesn't have that on mine, but it does on yours, and we'll start changing the videos off of that. I'm going to warp this thing by the displacement. Okay, and what you find is not much of anything. But what you can do is head on up, increase this. I may have gone too far. Sort of did. But what you'll notice is, take a look at the bottom. If you look at this, essentially you can see, and I might be able to see it better by looking at a profile view of it. Here we go. You can tell that essentially the table has held the original size of the ring fixed, and as you push it down, it's as if you took that table shut and created a stress around the ring in the edge. So you can see how you put a boundary condition can really affect your stresses. Now, just out of curiosity, okay, so you may have to remind me, okay, my E was what? Well, actually, if I look at my P over A as being you know, the stress. My P was 1, I think. My A was, you know, pi d squared over 4. I don't remember what d was. So I'm going to go back one. So now you see the sequence. I'm going to go back, look at my geometry. And then here, I don't even know. I tell you what I might be able to do. Let's do something weird. Okay, I'm going to drop another cylinder right on top of it. I'm going to move my radius until it matches. It says my radius was 20. I'm just going to close it. I'm going to head back off there. So my what did I just say? Radius was 20. Okay. So 1 over pi, and I don't have to use this one. I can just do 20 squared. What's that value? That's 1 over 3.14. 220. Isn't that 400? No, is that right? What number is that? That's tiny. That's a tiny number. Let's see. What is that? I can't do any calculation that has pi in it because I don't think my calculator has. It does. Does it? What's the size of it? Oh, that thing. Oh, my fingers are too big. The buttons get small. So I you can get it? Yes, sir. Oh, there you go. So I get about that. Wait. No, wait a minute. One of those. Okay. All right, scratch that. Okay. So that's what the stress should be. Okay. So let's take a look at it. Okay, that's not what it appears to be. So, but take a look. Well, there's 0.0. So, let's see. Let me go back and show it according to the other stress. That's okay. Okay, so let's back out of this thing, and I'm going to start messing around with this thing. So I'm going to go in, do common ones. I'm going to clip it. That's just fine. I'm going to clip it right there. And what happened is, okay, you better be careful. You got to get rid of your plane or you'll start moving your plane around. I could do all sorts of things to this clip. I could also slice it. Slicing it may be a better idea. Here, let me slice it. Slice it just takes a 2D cut through it. So here, I'll just go ahead and say, let's delete that. Go back to this, and this time, hey, filter common slice. The slice shows up, I think, about the same. And then you want to get rid of the show plane. So you're looking at this. I believe, if I'm not mistaken, I can go in and do a filter common. Oh, it wants to do contours on the full thing. Okay, wait a minute. Let's go ahead and do that. Hey, I just saw a calculator in there. Let's go back and do this. Let's do a clip like we had before. Get rid of that. Now I'm going to see if I can produce, well, the contours are not highlighted. Don't tell me I have to contour off of the original, which makes sense, I guess. Let's try to do a contour off the original. Contour is still not highlighted. So let me do a clip. I don't want to do that one. Let's delete that one. I do a clip, apply it. I wonder if it will allow me to do a contour off of the clip. It doesn't. Huh, that's interesting. Well, tell you what we can do. We can go in here and do this. I'll go ahead and take that, do the clip. or I can do it off of that one and delete the clipped. And here's what I'll do. I have a warped and I have my stresses right there, right? I may not like what I see. Hang on. Let me get the thing sitting there. But I should be able to edit. Wait a minute. Do a rescale. Now, let's see. It used to have a rescale. The rescale may have changed. Here, let's get rid of those. Now, I had the other stress showing up. Go back to that. Magnitude. Let's do, I forget my demi. Oh, ZZ. Okay. Well, it's hard to tell. The blue is a minus 0.818, and then move all the way down to the red, which is the dark red, is 0.08, which still isn't the same value. So we'll have to resolve that some other day or something. But I can put lots and lots of elements in there, and that may actually solve it. So that's a complete cycle, and we did that in less than 30 minutes. So the key is a lot of, it's like anything else. The grid, the creating of the solid's nice. The grid affects your solution. Choosing esters, good to, but how you convince your boss is in this part. You've got to figure out how to convince your boss of certain things. And you can do a lot of stuff in here, but you also need, there was a time I went, one of my first big jobs it was interesting because I was working, it's a big company, but there were 3 of us working together on this one little project. And one of the guys had a lot of experience. And so we ran a bunch of runs, and it turned out he spent a lot of time making the plots, and he made them all pretty, and it was all, we didn't have PowerPoint back then, but we did color slides and everything. And I realized that you soothe your boss by a lot of color slides. So it's often good to create good pictures at the very end. Not that I don't know what that really means, but that's what happened. So there's other things on here. Let's see. The texture. Okay. There's a lot of stuff to play with here. Let's see if I show. There's an axis that. Oh, I could have picked up the radius off of that. Oh well. I wonder what the edit does there. Oh, it's how you show different parts on the axis. Okay. Apparently they have added some stuff in here since I was in here. It looks only slightly different, but it's enough that if you come back 2 years later, it's not overwhelming. The only thing I don't see is there used to be a way to adjust the scale. Show, but maybe it's something beyond me at this particular point. But I'll take a look at that. So there's your whole sequence from beginning to end. Now the next key should be, and I can do that here, possibly. Let me see if I can do that. I should be able to share. Oh, I have no shared folders on here. What I'll do between now and next time is I'll make it so that these files get shared right into the Google Drive so that you won't have to worry about it. You can go straight there. So, are there any questions per se? Any comments or anything like that? I guess at one point we might do a simple, like a simple beam, and we'll do it in SolidWorks if somebody will do it. Essentially drawing a box. Who thinks they can draw a box in SolidWorks? Oh, and it'll be right here. Okay, that's what we want. We want to draw a box, and we want to compare this to that. Now, this is a free YouTube channel, so if it doesn't turn out very, very good, we can maybe send something to SolidWorks to get them to send us some donation money to our class. You know, maybe we could get some new computers or something so that they can beat this free piece of software. So, but you know, me, this is a personal choice.
So if you actually use this, like, you know, you had a job designing bridges or something.
Oh yeah.
Like, you know, went to the guy in charge and was like, hey, I use this instead of SolidWorks. Would you know, get mad and fire you?
Here, I'll show you. I'll give you added credence to this. Here. Just a few minutes. Okay. So if I go out and I say like, okay, Salome, I think it's MECHA. And then I say, oh, there's an official site. And then I say, oh, okay, well, wait a minute. What is this? Okay, Open Cascade and CEA. So let's look at each one of these. And then if you read in here, what you'll find out, I think I pushed too many buttons. You'll find out there's this company that has, under its umbrella, so to speak, done Open Cascade, which is essentially a CAD engine. It's like Parasolids or something like that, in which the engine sits under there. You can download it. I downloaded it one time. It's a gig long of source code that are all these objects. What they did, and I'm sure they did it in France, is they wrote a CAD package around that. And then they had the analysis package. So this company is actually the holder and owner of this code. So let's look at some facts on that company. And let's take a look. Okay, wait, I forgot. I'll have to go back. Come on. EDF. It's not running too fast here. Okay. EDF. Now, is that it? No, that's not it. Is it? Oh, was it? Okay. Oh, okay, there it is. I don't know what the extra digit's for. Okay. Okay, let me see if I can find somewhere in here. Okay, here we go. We'll do it this way. Okay. Oh, I should have thought about that. EDF, number of employees. Okay, let's take a look at it. All right, that's about right. Okay, this company has 158,000 employees. You take a look at it. Take a look at the top left here. Wait, control and do this. So essentially, it's essentially this drives it all.
Nuclear power?
Nuclear power out of France, which is the largest country. Don't quote me on this, but France produces more nuclear power than anybody else by a fairly long shot. They have figured out nuclear reactors and figured out all this junk. So this is supported. These codes are supported by a company that's massive, and so you can ensure that there's a complete development cycle. I mean, if you look and you go back to it, here you can go back to my. Okay, there's a download page. Well, now this is the other one here. Let me see if I can find. Okay, here's This one has the download page right up front, or maybe there's another button to it. Hang on. Let it come up. Just having to draw it from a long way away. Okay, come on. Come on. Oh, come on. But anyway, you'll find when it does come up that there's a fairly constant release cycle. There it is. So what you see here, I'll make it bigger too. So what you see is you saw February 2013, this day, they released this one. But of course you have to be careful. This is the 32-bit and this is the 64-bit. And then I guess they gave up on the 32-bit, which is kind of a common thing to do. You move into these other computers, you'll see how many releases do they have in this year? 2. How many do they have in this year? 2. They've already got 1 out. They're going to have another one. So its release cycle is the same as MATLAB. And MATLAB is a big piece of code. If you really look at this thing is massive. I mean, it's got a development cycle. It's supported by a massive company. If you start digging into Aster, you'll find it capable of doing all sorts of stuff. It's just that in this is a way of getting you on board, so to speak. So they have this flow, you can go through it and you can do some linear and elastic stuff. But they have 4 or 5 different methods of contact. There's all this stuff. If you wanted to learn more, and you don't mind going to Paris and you don't mind learning a little bit of French, which I know none of French, so I think I need to go there. So if I do that, essentially, it's as good as any code you could buy. The problem is when you look at when you're looking at all, you say it produces all these files, and you look at them, it's all written in French. So you see these funny letters, and you're like, what does that mean? Some of them you can read and kind of understand. Displacement is kind of DIS and a bunch of other letters. So I should know French. I lived in New Orleans for a while. But they have a funny version of French. It's Cajun French. So yes, the answer is you could find this thing would compete with anything out there from what I've seen. Has a good solid backing, a massive industry that supports it. If you look around, you just do a search of people who've used Codaster for some pretty large problems, you'll find a lot of people. People doing huge assemblies and all sorts of stuff. And they made it free. It's the same concept if you go look. I mean, they're not related, but the mentality is the same. I mean, I love MATLAB. I mean, that's what I use. I mean, but I have used this occasionally, and this one is a good secondary issue. If you need something real quick, you don't want to have to buy MATLAB. You just want to use it a little bit. Guess where this one comes out of? It comes out of France too, if I remember right. Let's see. Okay, here we go. History. Okay. So so I may say this wrong, but there were several people at this. It's not quite kind of like NASA, but it's a very similar version of the French version. I don't know, French National Institute for Research in Computer Science and Control. I don't know how that acronym turned up to be that way, but this part probably is a bunch of different words in French that probably means that. So you click that. Oh, and then it all comes up in French. But there's probably, there's an English version. Okay. So essentially, it's the French research leg. A lot of countries do that. Japan does that too. In other words, they will support a big section of research, and it's shared amongst industries in order to help the industries, which is not a bad idea. And guess what? You could just hit the download page, and you could load it into any of the Mac or Windows, or you can get the source code. Or, of course, here's Linux. And Scilab works pretty good. And so I don't know. But anyway, that's the end of that. So it is a big company, big back. There's a big backing behind it.
As far as so you have to download the Aster and other packages separately.
No, actually, it looks. This is the one I downloaded. I just downloaded it. It was big. It's like 1.3 gig.
And all the analysis packs don't.
All this, it's all good. It's way for like I waited a while. And they finally made it. This comes in this file that says such and such dot run. And then you get in a command window and hit run and it goes boom, 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 and it installs it. It installed this little window for me too. This little, which is good for me. I don't want to have to think about that. So, I did it in Linux because that's the only way this package comes. And then, hang on, let it come up. Then what happened is it installed this little button right there for me. So I didn't have to search around. How do I launch this thing, No, you just click that button, and then it takes a second, and there it is. And so then, okay, now it's down here. When you get it launched, it has this little, what is that, where they rub the genie in the bottle? What is that? That kind of looks like the genie in the bottle, or the bottle for the genie or something. And there it is, So, ready to go for you. Now, part of this, okay, so some of this is like some other companies. Part of this is borrowed. This part is not written in France. This is written in New Mexico, I think, or California, one of the two. That did the parody. If you go look out, what they did is they went out. Oh, there it is. It's still there. So there's the ParaView. Okay, and it comes, if you look at it, here, I'll even go do a search over there. This should come up under the, here it is, the Wikipedia or whatever it's called. And you look at it, okay, now, I may be wrong a little bit, but, okay, so see here, Los Alamos, I don't know who claims it. They claim it, they claim it, they claim it. So, it turns out Kitware has some stuff under it. But this you can install on a regular, so if you had some contour files, you can just install this package by itself on your Windows machine. It's a contouring package. So it's application well as a turnkey application. Okay, so it's open source, so you can download it, and it's got this huge files. And then if you download the source, then you can use it as a compiler. So that's nice that they actually just give you a binary. It works on Windows, Mac, Linux, and Unix workstation. It also works on clusters and supercomputers. So, and then it goes through this. I remember seeing, this was a while back, somebody running something on one big machine, and ParaView was plotting it while it was running. So I don't remember what they were running. It was some sort of chemical thing. And they were showing it running on the other while it was still running. And that was kind of impressive. So it has that has a lot of capabilities. So there's a big world out there with these open source things that are, it's kind of nice because, as far as what I've done here, I've installed VirtualBox. Under it, I installed Ubuntu. Then I installed Salome Mechanical, and then I'm done. So if you had a Windows laptop, you didn't want to install or rip off your operating system, you can install VirtualBox, which that's free. You just go out here. Right here, install VirtualBox. You'll see it looks kind of like that. It's pretty boring, but you see that icon. That's the one I installed. And here's some screenshots. So here you can run one operating system under the other. Well, that's not a very good I don't see anything there screenshot. Maybe the screenshots are. Anyway, you can see that these are different operating systems running underneath another one. And so what I did is I just decided, well, I just want to run VirtualBox and I want to run Unix on top of Windows. And everything we're doing here right now is just that. So essentially, I paid nothing. Except for this computer, which this is my computer. I paid for it. But I haven't done anything except take up a bunch of disk space, in using this. So here, I am going to click the close. Hey, wait a minute. So what we'll do is I'll go ahead and people are leaving now, either because I'm way too boring or they feel as though they haven't got much. And I will just save the machine state so we can turn it on the other day or in a day or so. After this stops, I'll stop the recording. Because apparently I can't get to it. There we go. Now I can double click this thing and then stop. And the thing I like, oh,